that smoke?
No.
I didn't think so. No? Okay. Good, then you don't got to go for smoke breaks. Just stand up and stretch your legs like Connor did. Yeah, so on your forklifts, of course, the lift lever, tilt lever, and side shift lever may be, they're often on the dash, sometimes they're over here. They're usually in that order, and you may have other levers depending on the functionality of the machine that you have. Signal switch or light switch, key switch, accelerator, capacity plate. Again, a capacity plate might be here, it might be on the dash. Everyone's a little bit different. It's important to get to know the machine that you're operating and figure out where all the quirks and features are. The parking brakes are sometimes, the Lindy has the parking brake on your foot. Other ones have a lever beside you, some have a lever on the dash. Just take time to get to know where everything is in the unit you're using. The operator position and restraint, position from which the operator controls the forklift, so typically the seat. It can be either standing or sitting. Forklift operators are required to use the operator restraint system or a seat belt, and that is one of our rules. You should always put your seat belt on. In the next, I'd say month, but around here probably 6 months, we are aiming to get to a point where you can actually be disciplined for not wearing your seat belt. So just keep that in mind. You should be wearing your seat belts at all times. It's extremely important for operators to wear their seat belts. You can actually be fined in the event an OH&S officer was on site, which they have been. They can fine you, and I know for a fact when they are on site, this is one of the few things they look for because it's really easy to tell. You can usually tell from a distance if someone driving a forklift has a seat belt on. They can charge you, they can charge your supervisor, probably go all the way up the ladder and charge Adam. But the unique thing about this is that they could actually individually charge you, and it's like a bylaw ticket, so it is enforceable, and you can get a $200 fine for not wearing your seatbelt. Again, the likelihood of that happening is pretty slim. I'd worry more about you getting a shit from your boss than getting a shit from the government, but it is a possibility. The key switch provides control to start and stop the internal combustion engine, just like in a car. 3 positions, start, on, and off. On electric forklift, the key allows electricity to flow from the battery to the drive motors and pump. The most common gauge on a forklift is the hour meter gauge. I can almost guarantee you this is a test question as well. Pretty much every piece of equipment has to have an hour meter. Other gauges might include the fuel, oil pressure, water temperature, and pressure. Service brakes are used to stop the forklift under normal operating conditions. So most forklifts are going to have 3 pedals: your standard gas pedal, your service brake, and your inch brake. These are things like getting used to the difference between the service brake and the inch brake is an important part of operation. Usually for just driving around, you're going to use the service brake. When you're lifting the forks up and well, not so much down. When you're lifting things up, you're going to want to use the inch brake. It disengages the drive mechanism so that the power all goes to the hydraulics. The inch brake works similar to a clutch, but allows the forklift to inch forward or backward to maneuver into position. So you can rev the engine, but it won't drive away on you. It'll accelerate the hydraulic pumps and make things lift faster, and allows you to get close to racks and move in close quarters without driving at high speed. But that's something you have to get used to. You typically use 2 feet driving a forklift. Unlike a car where you often use 1 foot, you'll find driving a forklift it's actually easier if you use both. 1 for the brakes and 1 for the gas, because you could actually, unlike a car where you're not supposed to ride the brake, in a forklift you want to ride the brake and you want to ride that inch brake when you're in close quarters. Clutch brakes allow the operator to increase engine RPM for lifting loads while stopping the forklift. Hydrostatic brakes work when the operator removes or lifts up on the accelerator pedals, which causes the forklift to slow or stop. The AUSA, the orange one, is a hydrostatic machine, so it operates differently than all the rest. But again, if you're not used to that one, you shouldn't be driving it. Other than that, everything else we have here is a regular setup. Park brakes hold the forklift in a stationary position. It should not be used to stop the forklift under normal operating conditions, unless, of course, you're doing some sick drifting. But we probably shouldn't be doing that, except, of course, in the winter where it's cool. No, all jokes aside, we should not be using the park brake to stop the forklift unless your brakes fail. I know I've used my park brake in my car to stop it when the brakes failed many years ago. Parking brakes can be hand applied, foot applied, or automatically applied when you leave the seat. Operators must press the foot pedal to release the brake. To stop the forklift, release the foot pedal, often referred to as a dead man switch, but it is not. Narrow aisle forklifts typically have one brake wheel as compared to sit downs, which have two brake wheels. The direction control lever are used to select the forklift direction of travel, either forward or reverse. They can be located on or near the steering column, on the joystick or lift lever for electric forklifts, on the foot direction pedals for hydrostatic. So we used to have one that had the foot direction pedals. We haven't got that one anymore. Most of them, it's going to be on the steering column. Have any of you guys ever driven a forklift so much that when you get in your car at the end of the day, you hit your turn signals?
Yep.
If you've spent a day operating a forklift and just sat in that seat or even hours, I've done it many times where I'll just half dead, sit in your car and go to back up and wonder why you're not moving and why your turn signal's on because you hit the lever on the tree. And that's just an indication that you've driven a forklift enough for that day. Anybody who says they haven't done that's probably lying if you've driven a lot of forklifts, because I've done it many times. I'll just back out of my stall. What the fuck? Oh shit, it's a car. Okay, fine. But we've all been there. Steering wheel allows the operator to control the direction of the forklift. It can also be a tiller type, so the stand-ups, you'll see one that controls it like this. Again, not something we have. If you ever leave here and go somewhere else, I assume you'll get fresh training. If you don't, if you leave here and go somewhere else in a year and they're like, hey, you have a ticket from LJ, cool, and they throw you on a machine you're not familiar with, ask questions. Don't just go, I've got the training, I can do this. Those stand-up lifts are a very different machine, very different animal. Don't just figure because you've taken this course you're good to drive them all. If you're not comfortable, that's that whole obligation to refuse. Just say, hey, I've got a lot of experience, but I've never driven one of these. Any place that's half decent where you want to work is going to work with you to figure it out. Usually that means put you somewhere wide open and let you play with it, but still, it's don't just go driving in the racks with a reach truck and be, I can do this, and then you end up knocking the racks down like the guy at the beginning. There are typically three different levers that operate the mast and carriage. You have the vertical lift lever, which lifts the carriage up and down, the tilt levers, which tilts the mast back and forward, and the side shift lever, which lifts the carriage or shifts the carriage left to right. Something I always point out to people that I know I look for in a forklift operator to judge if they've done it before or not is I will always, when I get in a forklift and I lift the forks up and I start driving, I will always center my forks. I will use that side shift, I will center that carriage in the middle. That way when I get to wherever I'm going, I can adjust my forks to pick things up. And then once I pick things up, I will readjust my forks to be centered. And that way when I get to the rack or wherever I'm going, I now have left and right movement. Otherwise, you'll see a lot of people who don't think about stuff ahead of time. They'll get to where they're going and realize they're already all the way to the left. So if you get in the habit of centering your forks every time you lift them up kind of thing, whether you have a load or not, it'll make your job a lot easier when you get to where you're going with a load, because you can now move it left or right, especially if you're lifting something 20 feet in the air to put in the racks. You're lifting it all the way up and now realizing that you can't move those couple inches to clear a pallet sucks. So if you plan ahead every time you lift something, it's also, like I said, it's kind of a little trick I use to tell if someone's driven before, but it also just makes life a lot easier. If you don't, I guarantee at some point you'll annoy yourself because you'll get somewhere and won't be able to deal with the thing you have. Internal combustion engines, the accelerator pedal controls the amount of fuel delivered to the engine, pretty self-explanatory. And with electrics, it controls the voltage delivered from the battery to the drive motors, so it makes things go faster. Backup alarms are used to warn others if the forklift is in reverse. Important for other workers to heed the warning and stay clear. The warning system is connected directly to the directional lever or transmission. Your capacity plates, and again, there's variations on these. They all look about the same. Legislation requires every forklift to show how much weight it can lift within its design. The plate must be permanently fixed to the forklift, and operators must not exceed the engineered capacity of the forklift. Again, later on we'll get into how to interpret these things. The plate typically shows the following information: the type and designation of the lift, the mass or weight of the lift, the capacity rating at a given load center, the maximum lifting height, the attachment types, and the minimum maximum battery mass if applicable. Because again, on an electric machine, the battery is considered part of the counterweight, so it's important to know how much that thing weighs. Plus, the batteries are really expensive. Important to note that as you lift the load, the capacity of your forklift decreases. Trying to figure out how to do this one. PC. So C is the height. So here's your different heights. And here's your different weights. So at 159 inches, you can lift 2,700 pounds. And 189 inches, you can only lift 1,500. And then it doesn't in kilograms to boot. But it's important to remember that if you're lifting up, just because you can lift it on the ground and drive around with it doesn't mean you should be lifting it 20 or 30 feet in the air and putting it in the rack. You have to consider only the one with the lighter stuff at the top. So consider all that, and a few different variations on capacity plates that just give you the different ways they're presented. Again, get to know the machine that you have. The tare weight is the weight of the unloaded forklift, so you'll see this on the side of trucks commonly. Your tare is just the weight of the machine, and your gross is the total weight of the forklift, including the load. So that'll be whatever your forklift weighs plus the maximum mass the forklift can carry. So in this case, the machine weighs 8,000 pounds. The maximum capacity is 4,000 pounds. So the whole weight should weigh 12,000 pounds. It's important for an operator to know the gross weight of the forklift to safely enter trailers, rail cars, and elevators. Yeah, if you're ever putting a forklift in an elevator, you probably want to know how much it weighs. You don't want to overload the elevator. Presumably the elevator is made to lift forklifts on the weight, but that's one of the times I definitely would want to know. Never done that myself. I've put plenty of forklifts in trailers. That's an interesting feeling when the whole thing moves and shakes underneath you, and then you have to worry about how solid the floor is. But yeah, when you're putting your machine in anything other than dirt or concrete, you want to know how much it weighs and make sure where you're putting it can support it. The load center of gravity is where the load mass is concentrated, usually somewhere near the center of the load. Pretty self-explanatory. That being said, LJ has a lot of unsymmetrical things. In a perfect world, everything would be nice and symmetrical. However, most of you guys have seen our equipment, it is not. Positioners are notorious for being incredibly heavy on one side. Our general rule of thumb here, if it has fork pockets, you have to use them. Just because there's a pallet underneath it, don't use the pallet. The pallet is just there to keep it out of the dirt. If you're picking up a piece of equipment, especially our finished goods, and it has fork pockets, use the fork pockets because it will be a hell of a lot more solid than using the pallet. And a lot of our stuff that we build is not remotely symmetrical, so consider that when you're lifting things up. Most often, forklifts are designed to lift a 4x4 pallet, therefore the center of the load center is 24 inches, or 2 feet, which is half of 4, from the heel of the forks. Make sure you consult the manufacturer specs for the equipment specs, so make sure you know the one that you're actually using. The calculation for figuring out if your forklift can actually lift what you're trying to lift. Calculate the capacity at a given load center. So you take your stated load center, which will be off your data plate, which is typically 24 inches, times your forklift capacity, which again is on the data plate, and then divide it by your actual load center. So if you've got a 10-foot long object, the center of the load is going to be 5 feet. Make sure you're calculating in the same units of measure. So if it's inches or feet or whatever, make sure you're using inches or feet and not trying to mix the two. It's going to give us a couple of examples here. So we take the stated load center times the forklift capacity divided by the actual. So a forklift has a load chart that states 5,000 pound capacity at 24-inch load center is being used to lift 3,000 at a 30-inch load center. I wish I had a whiteboard or something I could draw on here, but I don't right now. So is it outside the forklift's capacity to make this lift? So we take our stated load center of 24, times it by our stated capacity of 5,000, and then divide it by that 30-inch, which gives us 4,000 pounds. So the lift is within the forklift capacity. So that 4,000 is less than that 5,000, so we are okay. But that's just an example of how the physics work. Now your 3,000 pound object seems to weigh 4,000 pounds because it's kind of leaning off the front. This one here, forklift states it has a 5,000 pound capacity at 24. So now we take our 5,000 pounds of 24 and divide by 40, which is equal to 3,000 pounds. It's not within the capacity of 36 inches. This is all well and good. It's unlikely you're probably going to do that. A simple way to tell if your forklift can handle is if you start to lift things up and your back wheels come off the ground, that's a good indication your forklift can't handle that thing. It is useful to learn the weights of what you're lifting up, but that's probably not practical around here to get the mass of every single thing you lift. Most of the time, the things you're lifting, if you're just moving parts around the yard or parts into assembly or something, you're not going to be anywhere near your capacity. But if you find yourself lifting up entire pieces of equipment that are complete, as Connor, as you do a lot, that's where it starts to matter. You guys sometimes just can't lift the stuff you're doing. If you are taking finished goods out of assembly and putting it out in the yard, that's where we might have to worry about these things. Some of our equipment is incredibly large. Those CRRs are pretty darn large pieces of equipment. So just get to know what you're doing, talk to your coworkers, and that's going to help with most of our stuff. All your average pallets around here should be just fine. Fire extinguisher is important to be familiar with your safety equipment, ensuring workers are competent in the application, care, use, maintenance, limitations of the equipment, safety decals and markings, or reflective decals to mark floors or corporate areas. As per National Fire Code, portable fire extinguisher must be located on each industrial fuel fire lift truck. I looked into this because they just changed this course and put this in here. It's not necessary on ours. Our stuff is all close by. There actually doesn't appear to be anything in that I can find in OH&S that says there has to be a fire extinguisher on a piece of equipment. The main thing is you know where your fire extinguishers are. I should look into the National Fire Code part. That's a little bit different, but none of our forklifts have fire extinguishers. They're also propane based, so fire extinguishers not going to necessarily do a whole lot. But either way, make sure you know where your fire extinguishers are. There's a little video here we're going to watch that I have to get fired up. Give me a sec. It never works as well as I want it to. And I got a shiny new computer in here yesterday that screwed everything up. Bear with me, just relax, it's all good. Figure out how to make this damn thing play on that screen. Yeah, it's not like I can actually click to start it.
No, move more, move.
No, I'm going the wrong way.
Yeah.
That's the problem, stupid screens. There we go.
First time I did it, came like that.
Now the next trick is this is going to work. There we go. So mine is the full screen that makes it look like it was made in 1985. It's actually a pretty decent little video. Hopefully all this crap closes. There we go. I'll be right back. You guys will be excited by this later.
A forklift is a powerful and effective load-shifting tool that can be extremely dangerous if used incorrectly. Forklifts have stability characteristics that are not well understood by many operators, and this can lead to the risk of tip-over. If you understand and follow the principles of forklift stability, many accidents can be avoided. You can't afford not to be stability aware. This program covers the stability triangle, longitudinal stability, lateral stability, load capacity, dynamic stability, the working environment, and forklift tip-over procedures. Understanding how a forklift becomes unstable is essential to safe operation. The center of gravity is the point in an object at which all of an object's weight is concentrated and is the balance point. An object is said to be stable if its center of gravity lies within the outline of its points of support. The center of gravity of an unloaded forklift lies at a point just behind and below the operator's seat. Both the forklift and any load it carries have an individual center of gravity. When a forklift lifts a load, the two centers of gravity form a combined center of gravity that is always placed somewhere between the two. You need to understand how a forklift's center of gravity can become unsafe, resulting in a tip-over. Although most forklifts stand on 4 wheels, the hinged rear axle makes the forklift behave as if it were standing on only 3 wheels. This creates a stability triangle that is used to determine a safe center of gravity when operating a forklift. The corners of the stability triangle are formed by the center of each front wheel and the center of the rear axle. The center of gravity of a forklift must be kept within the stability triangle or it will tip over. A forklift's center of gravity can move outside the stability triangle in 2 directions: longitudinally, or forwards and backwards, and laterally, or sideways. Which points of the forklift make up the stability triangle? In most cases, forklifts are counterbalanced, and the fulcrum or lever point is the front wheel axle. This means that the load carried by the forks is counterbalanced by the weight of the forklift body on the other side of the fulcrum point. In this example, the load carried by the forks is too heavy for the counterbalance. The combined center of gravity moves outside the stability triangle in front of the axle, causing the forklift to tip forward. Even a safe load can make a forklift tip forwards if the load is picked up on the tips of the forks, or the load is tilted forward. This increases the distance of the load from the wheels and moves the combined center of gravity outside the stability triangle. Driving down an incline with a load downhill can shift the center of gravity outside the front axle and cause the forklift to tip forward and lose the load. What makes a forklift counterbalanced? Lateral instability occurs when the center of gravity moves sideways outside of the stability triangle. For example, driving across an inclined, rough, or uneven surface can move the center of gravity to the side of the forklift and cause a side rollover. Tip over while cornering is a common accident caused by cornering too sharply, cornering on an incline, or driving at too high a speed. As you can see, the center of gravity moved sideways outside the stability triangle, causing the forklift to tip over sideways. Forklifts have the lowest lateral stability when the center of gravity is furthermost back in the safety triangle. This occurs when driving unloaded, tilting fork masts backward, and driving up an incline. This is because the center of gravity lies in the narrow part of the stability triangle, and its line of action only has to move a small distance to be outside the stability triangle. Always drive your forklift cautiously and at a safe speed. When is the lateral stability of a forklift at its lowest? When you pick up a load, it will change the center of gravity of the forklift to a combined forklift and load center of gravity. Forklifts have a load capacity plate that includes information on the maximum weight and the maximum load center distance of any load that can be moved by the forklift. The load capacity of a forklift is the maximum weight it can lift at a specific load center distance. The load center distance is the distance from the vertical face of the fork to the center of gravity of the load. The load center distance of a load changes the center of gravity of the forklift, which varies according to the load and mass lift height. In this example, the combined load center and forklift center of gravity are safely within the stability triangle. However, if the same load was raised on the tips of the forks, the combined load center and forklift center of gravity moves outside the stability triangle, causing the forklift to tip forwards. Keep in mind that any increases in the load center distance will decrease the weight of the load you can safely carry. Carrying a load on only one of the forks is inherently dangerous and causes sideways instability. Always ensure the load center is in the middle of the forks, especially when carrying a long or wide load. In some cases, you may need to use a load spreader so that the load center can be kept in the center of the forks and the load can be better supported. You must understand the weight of the load to be handled. Weigh your load, check the paperwork, or calculate the weight by breaking it down into individual units. Your load must weigh less than the capacity indicated on your forklift's load capacity plate. Forklifts are often unwittingly operated at the edge of their stability envelope. If the back wheels lift from the ground, your forklift will be many times over its safe load limit. Attachments are used for unusual loads and will change your forklift load capacity due to increased weight. How is the load capacity of a forklift measured? A forklift may appear stable when it is static. However, dynamic forces that result when the vehicle and load are put into motion can be potentially fatal. To understand some of the dynamic effects when a forklift is moving, it may help if you think of a heavy steel arrow hanging freely from the center of gravity. This arrow will always point to where the center of gravity is acting when the forklift is turning, braking, or moving on an incline, and represents the apparent shift of the center of gravity. Dynamic stability incorporates both longitudinal and lateral stability. When an industrial truck fitted with a jib lifts a freely suspended load, dynamic stability changes. As the industrial truck turns a corner, the load will normally swing out, decreasing the truck's stability. As with all attachments, the load capacity must be reduced when lifting a freely suspended load, and you must refer to your forklift supplier to update the new load capacity. There have been a number of fatalities when forklift operators attempt a sharp U-turn with no load on the forks. The center of gravity moves outside the stability triangle, and the forklift turns over due to the dynamic force of the movement. Stopping a forklift is not the same as stopping a car. A forklift has only two small braking wheels. Keep in mind, studies have shown that if you are traveling at 12 kilometers per hour, it can take you 7 to 8 meters to come to a safe halt in an emergency situation. If you brake too quickly, the result is dynamic instability and a tip over. Even while traveling at 6 kilometers an hour, it can take you 2.9 to 3.2 meters to come to a safe halt in an emergency. This distance may double if you are distracted or are traveling on a slippery terrain. Accelerating backwards too quickly can cause the center of gravity to move outside the stability triangle, resulting in a forward tip-over. Dynamic stability is also affected by the movement and position of the mast. For example, if the mast is moved to full forward tilt, the center of gravity moves forward. If the forklift is driven while the mast is in this position, the center of gravity can more easily move outside the stability triangle and tip over. Stability is greater when a load is lowered before traveling. Raising the load to see under it is an unsafe practice. The forklift could tip forward, and it limits braking due to the propensity to tip forward. If you can't see over a load, drive in reverse or have somebody direct you. Never travel with a load or the forks raised, as this causes instability in all directions. If the machine is not in good working order, dynamic instability can occur. Always carry out your pre-operational and startup checks and report any problems. What is the difference between dynamic and static stability? Whenever you undertake a task, it is essential to assess the effect of the specific operating environment on your forklift stability. The surface the forklift operates on can cause serious stability problems. While driving up a gradient, the center of gravity is moved backwards in the stability triangle. If you drive a forklift on an incline, you must keep the load on the uphill side. Do not reverse up an incline. The center of gravity moves far outside the stability triangle and can cause the load to fall off and the forklift to tip. Never drive with the load facing downhill. If you can't see over the load, get someone to direct you. Never drive across a sloping surface, as this causes severe sideways instability. Drive directly up and down a slope. Uneven floors, rough terrains, loose objects, bumps, or depressions can cause instability. Avoid driving over loose objects or on surfaces with ruts and holes. Most hard-tired forklifts are designed to operate on hard, level surfaces and can be dangerous on loose gravel, snow, or ice. Specially designed forklifts are to be used on unsealed surfaces. When traveling on wet or slippery surfaces, reduce speed and proceed with caution. Turn corners slowly and drive in a manner consistent with operating surface. Snow can fill in hazardous holes that can cause the load to be dumped, or worse, cause the forklift to tip. Drivers should take additional time to check that the driving path is clear and stable. Never drive across frozen water. Which side must the load face when driving up or down an incline? If you are involved in a forward or sideways tip-over, you must know what to do. A seatbelt can save a life or a limb. In a tip-over, a seatbelt can prevent you from being thrown into the mast or outside the cage. This operator stayed in the vehicle with the seatbelt on and was saved from serious injuries. Never try to jump clear or throw yourself out of an overturning forklift, even if there is no seatbelt provided. If you do, the overhead guard can crush you against the floor. Always stay inside the confines of the truck. Brace yourself by grabbing the steering wheel or overhead guard and planting your feet firmly on the floor panel. Lean away from the direction the forklift is tipping. Head, neck, and spine injuries are not uncommon when a lift truck tips over. However, if you stay within the truck, you should survive. Wear your seatbelt at all times. What can you do to prevent a forwards or sideways tip over? The number of deaths and serious injuries that occur each year show that a forklift can be dangerous if stability is not understood. To prevent your workplace from adding to these statistics, make sure you understand the stability triangle and the consequences of forward, sideways, and dynamic instability. Understand load capacity and safe traveling speeds when you operate a forklift. Never let your concentration slip, not even for a moment. Your life could depend on it.